All right, good.
All right, everyone, good morning. Welcome to class. As you walked in, I gave everyone a little paper triangle. So what we're going to do right now is I'm going to ask everyone to go around the classroom and find someone who has a triangle that's congruent to yours.
Oh.
Yeah, so I kind of just made three congruent triangles. If this was a bigger class, then I would have made them a lot more different. But so you guys all found, you're going to be working with these, the people that have those congruent triangles with you today in groups in our activity and things. So just stick with that group. But before we start, how did you find out that how did you find your partners? What did you use to find out?
We tried to line them up.
And what did that tell you?
Well, congruent means that their angles and their side lengths are the same, so you are able to line them up and they match perfectly, then the angles and side lengths are the same.
All right, very good. And then I can't really do this because we have smaller groups, but if there was another class, then I would probably have triangles that were bigger but very close, so we can talk about similarity as well and push that a little bit just to make sure students know and remember those things before we get started in the actual lesson. But it's a lot more difficult to do that with just three people. So today we're gonna do an activity online, so if everyone can get out of their computers and go into Google and search Illumination's congruence theorem. You should come up with a page that looks like this, that has this little activity there. And if it doesn't work, then you can get next to someone and work with them if you need to do that. But I'm going to briefly show you how we're going to use this tool, and then I'm going to give you guys some time to kind of explore that and talk about it in your groups. So as it says at the top, you want to choose 3 elements to make a triangle. So we have these little squares up here, and you can choose any 3 of them. So for this example, I'll just pick the 3 sides. So now it says to connect the elements to make a triangle. So if we're going to make a triangle, if we're going to connect these elements, how exactly can we do that? Where do we connect them? We just have some lines here, but they're labeled, so how do we know where they can go?
Point to point?
And what point to what point?
Like C to C, B to B, and A to A.
Alright, good. So we want to try to move them so that they match up with their points. Now if you select the point in the middle, it allows you to just move it around. You can use a translation, move up, down, left, and right, move it all around however you need to do that. If you click on the side, you can do a rotation and rotate it side to side. So what you'll do is you'll put them up close to each of the points that they can connect and rotate and shift it around until you can create a triangle with it. And then when you create a triangle, it should make it solid and show you that you have your triangle. Does everyone have their first triangle finished? So once you have that, the little app will give you 3 more lines. And so you'll do the same thing. Just move them and create a triangle with them.
way.
They're all connected to the right letters, right?
Yeah.
Don't know why that's doing that.
There we go.
So now, once you get your second triangle, and I know Nick's just finishing up working on it, but at the bottom it'll ask you if the triangles are congruent. So how can we tell if these triangles are going to be congruent?
The same way we did.
The same way we did that, right? You can move the triangle around, and you can try to see if it's going to match up. So what are some different ways that we can change this triangle so we can find out if it matches with this?
Flip it?
Flip it. So we have an option to flip. What is that called when we flip something on a graph or flip a figure? What do we call that?
Reflection.
A reflection. Good. We can also do this to it. And what's that called?
Rotate.
Rotation. And then we can move it side to side, and what's that called again?
Translation.
Translation. So now if you move it around and you put them together, we can decide if we think they're congruent. And if we do, we can answer yes or no. So in these triangles that we created, are they congruent? And that is correct, they are congruent. So then the next thing that'll come up is it will ask you to see if it's possible to make a triangle that is not congruent to the first two triangles that you created. So what we're going to do now is just take some time, talk within your groups, talk about different things, and try to find different ways to see if they're always going to be congruent, if there's a way to make them not congruent, and just kind of change that around. If you think that you understand and you think that you have your answer for all three sides, if you hit new, it'll reset the whole thing, and you can choose any three of these elements. So you can choose two angles in a side and rotate and mess around with that. So just take a little bit and start doing that. Talk with your partners, maybe see how you're all thinking differently and find different ways to do that.
So the points have to be the same.
Right.
So then it's like,
Right, real quick, everyone look over here. If we have a triangle, if we're looking at the sides, and where the sides meet, what do we call where the sides meet on a shape or a figure like this?
oh, okay.
A vertex. How do we name a vertex? Like, it's super simple. What do you call that vertex?
A.
A. Just one letter, right?
Yeah.
So then this one would be,
B.
and this last one would be. Would you call this one B as well? No. So you have to keep that in mind when you're looking at the triangles that they're giving you on the screen. That those points where those sides meet or where that angle is, they have to be that same number, because that is that one name for that specific vertex. Just keep that in mind when you're looking at the different options that you have on your computers.
Okay. So I line them up. So like I know Q's gonna be up here somewhere. So I try to get the right like angle, like so they're parallel. And then I like just put Q Q if I need to. And I just move Q down until I know I cross it at J. So it would be hard.
So you're trying the angle one?
I'm doing that one right now.
It won't let me make a triangle. There it goes.
Make sure you're talking with your groups and comparing what you guys are looking at and what you're coming up with. Okay, maybe you guys just ask the question process. Make sure you're looking at it.
I feel like they're not
Yeah.
perfect.
Same.
When you did the angles, they're not gonna get.
Mhm. Well, you can make them, I mean, you gotta be really exact to make them congruent.
But they look good similar.
What did you say, Linda?
The angles look really similar.
What does that mean?
Well, they're all the same angle, but they're not the same size, but it just looks like one is a couple times bigger than the other. Okay. So,
I wonder if angle side actually work.
neutral?
So what have you tried?
Angle side. The inverse to the left.
And maybe just on a piece of paper on the whiteboard table, just kind of write down some of your findings so you don't forget. So then we can bring it back into the discussion. We can talk about what you found compared to other groups and other people. You're a little frustrated, Nick, because they're really...
I thought angle side doesn't work.
No.
Rearrange the letters.
If you're really confident, then try taking a look at it from a different perspective.
Did you say side angle or?
Angle side.
I guess you could say that if you have an angle side.
Has everyone tried every combination? Alright, so why don't we just take a couple minutes, I know we might not be completely finished if we can get everything, but, talk to your partners and just see what things they come up with, they observed, and see if there's any ways, any points that you agree or disagree on anything.
This one on side angle.
That's what I'm doing too.
Side angle.
Mm-hmm.
Side angle, I found too.
But
Maybe even compare your computers, maybe that might help. If your group seems to be stuck on something.
what does yours look like?
I moved on to angle side, so
Oh, okay.
let me try again. What angles and sides did you pick though? Like,
No, see, that doesn't matter. I've done that. I did that.
you did all of the possible,
Yeah, they just keep coming up side angle. Oh, like AB, ABC, AC?
Mhm.
Oh.
Oh. So that was not congruent.
You did?
Yeah. So like, I think it's like, okay. I don't know.
I think it's not gonna let you,
so I did A, B.
it'll just show the three. But why don't you table that for right now, Linda, and you can bring that up in the discussion? Like normally you'd probably tell that to your partners and explain them, but, since this is the only, like, class, kind of treat them as if like the other students that might not pick up on what you just found. That's a good point. Alright, so let's bring this back into discussion. What kind of things did you guys found? What did you conclude about any of the, different combinations of sides and angles? Was there anything that you guys, that your group had in common, that you were all like 100% that is congruent or is not congruent?
Angle. It's not congruent.
Why is it not congruent?
Because the lengths of the sides, you can like move the angles in or out to be whatever you want the lengths to be. So like the lengths can change, even though the angles always stay the same.
Can you draw an example of that on the whiteboard? Just so everyone can see it.
So if they tell me this angle is this angle is this, and that angle is that, I can either connect them or I can move this angle, like I can move them.
You can stretch or shrink it.
Yeah.
Right. So having the same exact angles, you can have one in here. Right. The angles are still the same, but the sides changed. So those aren't congruent because they're not exactly the same. Is there anything else that you guys found that you guys agreed on?
Side.
Right.
It's congruent.
It's congruent. And why is that congruent? Or why do you think it's congruent?
Because like when the sides are the same length, you can only connect them one way.
Okay. Now, is there anything that you disagreed on or had trouble with?
Angle
I know there is, so.
Angle side.
Angle side. What were you stuck on when you were looking at that?
Because I've always been told that angle side will never work. And when I was doing this, so it always came up side angle, but it's the same thing. Like you can write it backwards and forwards. But I always would always make it work. Somehow, some way. So I don't know what to think.
Does anyone feel incredibly confident about their answer, whether it's congruent or not congruent? Linda,
They're not congruent.
would you mind showing us on the computer if you want to use the touch or if you want to use on the computer, whichever you're more comfortable with? It just shows so that everyone can understand. Maybe even like as you're making the triangles.
Yeah, let me try. So, I first found that they were congruent, but then I found that they weren't, because like, if I make this one here, and then I connect over here. So if I connected this part, so that's my angle right there.
Move it up a little bit.
No, move it up.
Like up to the left.
It might not connect to the point of the arrows, but
Oh, there you go. Yeah. So like this part's the angle, and then if I do this again, so now this time instead of just like leaving it like this, I can. Here, I'll do this. Let me spin this around. And if I let this length connect to a different part on the line, then it gives me something different. So it's about like this side length. So because this third side isn't the same, it causes it. And then if we do this and compare it this way, and so like this is my angle right here. And so my angle is the same, and this side is the same, but because I elongated this side here, these two become different.
does everyone see how she got that? Thank you very much, Linda. So, what we're going to do next is kind of explore how exactly we can show this. Not just in like doing pictures like we just did, but how we can show it with information that we are given. So, I have an envelope here that has a picture in it, as well as like a few statements. So, Hattie, if you can kind of gather around them so that you can all see it. And you can turn off your computers and put them off to the side, because we won't need them anymore. So if you open up those envelopes, you'll find that you have a picture and a bunch of papers with little statements on them. So if you just want to gather them around and just have all the papers out. All right. So, what this paper shows us is it shows us information that they are giving us. They're telling us that this information, angle 1 is congruent to angle 2, angle 2 is congruent to angle 3, and so on, are true. So you can, looking at those, you know for a fact that those are going to be true. So what you're trying to do here is say that using all of this information, how can we show and be 100% certain that these are true? That angle AEB, the angle on the top, the triangle, angle on the top, and triangle DEC are congruent. So, in the past lessons, we have talked about proofs, we've talked about different properties and things. So, we'll want to kind of take a look at some of those and use what we can to try to get to that proven statement. So, where do you think we would start?
With the given.
And how would you do that? Hattie, can you explain to the larger class what exactly you just did?
So you
are given that angle 1 is congruent to angle 2. So on the left side, I put angle 1 is congruent to angle 2, and then my reasoning is that that is given.
All right, so,
In the beginning, sorry.
like Hetty explained, she has the statement, that being that angle 1 is congruent to angle 2, and the reason is that that was given. So what is another assumption that you can make when you keep going with this? What can you add to that next?
Angle 2 is angle equals angle 2 is congruent to angle 3.
Angle 2 is congruent to angle 3. And what is your reasoning for that, Nick?
That's given.
That is also given, because it's listed right there. So what do you think we would do next?
We know that segment EB is congruent to segment EC.
Okay, and why is that?
Given.
It is also given. And what would be next?
AE is congruent to DE segments.
AE congruent to DE. And that is because
Given.
it is given. So now what can you say?
That angle 1 is congruent to angle 3.
Okay, that's just, and why can you say that angle 1 is congruent to angle 3?
The transitive property. Because angle 1 is congruent to angle 2, and angle 2 is congruent to angle 1. So by transitive property, angle 1 and angle 3. That's angle 2 is congruent to angle 3, and then angle 1 is congruent to angle 3 through that.
Right, so when we talk about the transitive property, you have three parts. You have angle 1, you have angle 2, and you have angle 3. And since you know that those three parts are equal to each other, you can take those two outer ones, which in this case is 1 and 3, and say that they were also equal to each other. So now, I know when you look at what you have left, it's pretty obvious how it's going to end. But why exactly does that show that those triangles are congruent?
Well, you first proved that. So first of all three are congruent. So you know that angle 1 and angle 3
All
are
three what are congruent?
and all three angles are congruent.
Angles, okay.
So then you know that angle 1 and angle 3, they're congruent in their respective triangle. And then you know that EB and EC are congruent. So you know that you have the side angle, and then you just need one more thing. And so AE and DE are congruent, which would be side equal side.
Right. So, using and looking at what we were given, we know that EB and EC are equal, or congruent. So we know that those two sides are congruent, correct? And looking at the other one, we have AE and DE. They are congruent. And then we use that transitive property to show that these angles here are congruent. So now we can see that by using these statements that were shown, we know that the side here and the angle here and the side is equal to this side and this angle and this side. So talking about the side angle side, which was one of the possible options when we were looking at the illuminations app, is that these are going to be equal. So that's just a very simple kind of way to show how we can get down to equal and how we can get down to show for sure that these are going to be possible. So what we're going to do now is I'm going to give each group a different one, and you guys are going to work on it on your own. So do you guys want 4, 5, or 6?
5.
5?
Oh.
All right.
Okay.
As a group, sorry.
Without, I got it.
So,
I thought you meant individually.
yeah. So as a group, open up your envelope, look at the proof that you have, the pictures that you have, and the statements that you have, and try to come up with what you think might be the best way to show that that is for sure the right way to do it.
Should we separate it to like your column and my column?
Yeah.
But this is cute.
JK and JM. That's also given.
And then the specific column.
JK down here. Okay.
So how do we know this? Oh, so we're given that,
NM and MK.
no,
Square.
yeah, because NKLM is a square.
And then JN is JN because they're reflexive property. And then we can prove the triangle JKN, JNN.
Okay.
Alright, so, time got a little away. I teach in trimesters at my student teaching, and that's kind of how I base this around, which is 70-minute classes. So in the class, I would have more, and I would have, each group would have different proofs to show, and they would create like little posters to do that, to show to each of the other groups, so that they can all see like different perspectives of each of the things to show, like, you know, one way that you can show side, 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 one way that you can show side on side, and so on. And then we come back and close it by talking about the different ways that we proved it, and also discussing the order that you might put them in. For some people, it might be easier to say that if you put the transitive property here instead, to have that come directly out of these two givens and not separate them, and talk about how important that might be, and if it significantly changes or anything. So yeah. Cool.